DeFi or decentralized finance is another very popular stream of blockchain technology. The availability of DeFi protocols open doors for many to invest and trade cryptocurrencies. It will be interesting to understand the know-how of protocol development. If you are a DeFi protocol developer and interested in learning about standards proposed for token state fingerprint, continue watching. Welcome to PEEPanEIP episode 90, a series dedicated to Ethereum improvement proposal for protocol development. I'm your host Pooja Ranjan. In this special episode on DeFi, we will learn about EIP-5646 token state fingerprint with Naim Ashhab. Naim is the author of the proposals and a developer at PWN, a DeFi protocol on Ethereum mainnet to unlock peer-to-peer lending using any token as collateral, NFTs included. EIP-5646 was created on September 11th and is currently in review status. According to the proposal, the specification defines the minimum interface required to unambiguously identify the state of a derivative token without knowledge of implementation details. We will learn more on EIP-5646 with Naim in the next few minutes. Thank you for joining us on the show, Naim.
Hello, happy to be here.
As exciting as DeFi is to the community, I can't wait to hear what this proposal has to add to the protocol developers. May I suggest kicking off today's talk with a brief introduction and your journey with the Ethereum blockchain before diving into the presentation?
Yes, sure. So, hello, my name is Naim. I'm a smart contract dev at Pawn. Pawn is a peer-to-peer lending protocol on Ethereum mainnet and Polygon. And it's tried to be as open as possible, so you can use any standard token, which is ERC-20, 721, 1155, as a collateral, and there is no whitelist. So if you can find a lender, you can borrow money and proceed with a loan. A bit about myself. I studied computer science at the Czech Technical University in Prague. After that, I was developing mobile apps for 7 years before I switched my career into Ethereum smart contract development, which was around 2 years ago. So yeah, that's for me.
Interesting. Thank you for sharing that. So without further ado, let's peep into the proposal.
Perfect. So let's just briefly say what I'm going to talk about. First, we will talk about types of token based on a state mutability. Then we will talk about some challenges of supporting mutable tokens. We will ask a question if we even need a standard for that. Then we will show some existing attempts. After that, I'll tell you what the EIP-5646 actually is and what it specifies. And at the end, I'll show some implementations examples, how you can actually implement this EIP. So let's go. Types of tokens based on state mutability. So first of all, you have tokens without any state. This is basically token without any additional data stored on chain. All you need to know is the token ID. If you are the owner, you have all the value of the token. Some examples are the most known PEEPanEIP collection as Bored Ape Yacht Club, CryptoPunk, or POAPs. Then you have tokens with the state, which is immutable. So the token holds some additional data mapped to the token ID on chain, but they are not changed during the life cycle of the token. So they are set on the mint, and that's basically it. You can imagine some examples as a static token bundle, where the bundler itself stores the array of the assets which the bundle ID holds. Another example could be some static derivative token. But what interests us the most is a token with a mutable state. By that, I mean it's a token with additional data stored on chain, which can change during the lifecycle of the token. So basically, the holder of the token can store some or update some state properties during the lifecycle of the token without changing the token ID, without burning the token and minting a new one. So examples of those type of tokens, it's Uniswap v3 LP NFT. You can imagine some gaming assets as CryptoKitties or Avagochis, where you have like a variables and you can change them as the owner of a gaming asset. You can imagine a metaverse land where the parcel ID is the same, but what you build on the land is a different. Or some dynamic token bundle, where this is like a modern approach to that, where you basically like deploy a proxy and you tokenize just the ownership. Okay, so we will talk about the mutable tokens. So what are the challenges of supporting these mutable tokens in a DeFi protocol? Let's show it on an example. So imagine you have a seller or a holder of a LP token, which has a mutable state with 100 XYZ tokens and 10 ETH, like a liquidity. And you have some naive buyer who don't know that the holder of the LP token can actually change it and is offering a 20 ETH for this LP token, believing that it's a fair price and he can buy it. What the holder of the LP token can currently do is to withdraw the whole liquidity. So basically leaving the token empty without invalidating the offer. So the offer is still valid, and the holder can accept it. And if he accepts the offer, the seller basically rugs the buyer, right? So buyer bought an empty LP token with 0 value for 20 ETH. So that's definitely something we want to protect our users from. So yeah, this is an issue for most of the DeFi protocol these days. And it could be a marketplace, it could be a lending protocol, it could be an option protocol, just name it. Basically anything where there is some kind of offer and you are trying to like identify some token, which is the problem, because currently you identify a token with the contract address and token ID if we are talking about NFTs, because these are the standards, right? ERC-721, that's what we use mostly, or 1155 if somebody wants to use this standard too. So if marketplace want to solve this issue, it would need first to know that the token is mutable, because from the protocol perspective, it's valid ERC-721 token. So there is no reason for the protocol to manage it differently than any other token. So yeah, first it needs to know that this token is mutable, and it's not enough that the contract address and token ID is used as an identifier. Second, the protocol needs to know the implementation details of, in this case, the LP token. So the protocol can put the state properties into the offer. So if the holder of the token change some state of the state, the offer will be invalid. But this brings like obvious bottleneck, because protocol will need to support any mutable token one by one specifically, which does not scale, and that's something we don't want to do. So yeah, just to sum it up, what we need right now is to add some additional data to the way how we identify tokens, specifically the mutable ones. So next to the contract address and the token ID, we need some additional state data. And with that, now we can word an problem, a question what we are trying to solve. So how to unambiguously identify a token state without the knowledge of an implementation details. If we divide this sentence into two parts, the first is how to unambiguously identify a token state. This is basically saying, hey, I really don't care what the state is. I just want you to give me different state, different identifier for the different states, and same identifier for the same state. And the second part, without the knowledge of an implementation details, is I don't care what the state is. Yeah, I want to work with any mutable token the same way. I don't want to distinguish between them. So yeah, now we have the question, the issue, the thing we are trying to solve. We can look at the example of ERC20. What the ERC20 actually did is creating an agreement between basically a token and DeFi protocols about what the token will implement, how the minimum ABI will be implemented, so the protocol knows how to transfer the token, how to approve another address for the transfer, how to get the balance, the total supply, and some metadata information. With that, it's not even saying, hey, nothing else can be implemented. It's saying these are the requirements, so the DeFi protocols can work with any token implementing ERC20 the same way. So for the token dev, if I implement ERC20 token, I know that any DeFi protocol which works with these type of tokens can support my token out of the box, which is great. But without the standard, the DeFi protocols would have to support the tokens one by one, figure out what transfer function they use, if they even have the approval, and so on and so on. So again, it doesn't scale. We need some standards to create agreements. This is like a visualization of the same problem. Right now, if we want to talk about mutable state, this is like the current setup in these days. The protocol needs to support ABI1, ABI2, ABI3, and support every token individually. With the standard, you can do the same thing as with ERC20 or ERC721. You can just ask if the token implements this standard, and then use the defined interface to interact with it. So this is great. This is the money Lego narrative we want to push. This is something which scales perfectly. So yeah, let's aim for that. There were already some existing attempts to do that. First, I'll talk about token implementing some sort of state hash function. So I found two projects, Blockheads and Mokens, where Blockheads defined token metadata hash function, which returns some sort of identifier of the state, and Mokens get state hash, which is doing basically the same thing. Unfortunately, these two projects are not aiming to standardize these functions. They were implementing it because they were using it internally in a different contract, but the need is obviously there. So if you have a mutable state, you somehow want to distinguish between different states, even without knowing what the state actually is. And if we talk about standards, there were a proposal, EIP-1180, which unfortunately didn't make it to the repo. It was it was just an issue, like a discussion, called non-fungible token state verification for exchanges. From the EIP, secure exchange of NFTs. This EIP tries to basically prevent the seller in our previous example with this seller and buyer to rock the buyer. So it was great. Yeah, it's in the right direction. The pros of this proposal was that buyer can specify which attributes he's interested in. So let's say buyer wants to buy a CryptoKitty, and he's saying, "Hey, I'm interested in this, and this property, and this is the offer. And you cannot change this property or the offer; it will be invalid. You can change anything else, but not these, not this set of properties." Unfortunately, for that, the protocol needs to know the implementation details of the token. So it's a good way, it's a good start, but it's not really solving the issue we have right now. Another attempt was EIP-1948, called non-fungible data token from the EIP. Non-fungible tokens are extended with the ability to store dynamic data. This is really almost what we were looking for. This almost solved the problem with the unambiguous identifier, state identifier. So it can be almost used as a unified ABR for mutable tokens with the read data function. Unfortunately, in the spec, there is also a write data function which stores the new state hash. This don't give the devs really the flexibility to compute the state hash on the fly, and specifically to add some condition into the state hash. So token cannot use, for example, the block timestamp as a condition in the token state for expiration date, maturity date, whatever. And also when I read the EIP, I had this feeling that the data stored in this field through the write data are not really the state of the token, but like additional data for other DeFi protocols to somehow work like better with that token. So they mention bridges. So I don't really think they're aiming to solve the same issue, even though it was very close. And of course, the biggest con is that it's stagnant and it feels like the EIP is abandoned. Okay, so now let's talk about the EIP-5646. The EIP looks like this. It's a minimum interface defining just one simple function called getStateFingerprint. It gets one parameter called token ID, which is unsigned integer. It's the ID of the token state in question, and is returning bytes 32, which is the current token state fingerprint. This interface also has to implement ERC-165 to be discoverable by the DeFi protocols. Great. So this EIP doesn't specify how to compute a state fingerprint. The state fingerprint can be stored or computed in a contract. It really depends on the needs of the devs, how big the state is, what exactly is stored or computed, but it gives the devs the biggest flexibility. But the function has to implement some requirements. So if we go quickly through them, the getStateFingerprint function must return a different value when the token state changes, and must not return a different value when the token state remains the same. This is basically the first part of the problem we defined previously on how to unambiguously identify the state. This is basically saying, hey, for the same value, return the same fingerprint. For the different state, return different fingerprint. Cool. Next point is the getStateFingerprint must factor in all parameters that might change the state of the token. This is a little bit poorly phrased. I may change it in the future, but what I'm trying to say with that is the function has to count with all parameters that can change in the lifetime of the token. So basically, it doesn't really make sense, or it's unnecessary to compute with all parameters. I will have an example later, but just quickly, let's say you have a state with 8 properties, but only 3 of them can change, and 5 of them are like static. They are set on the mint and cannot be changed. They're immutable. Then you should not be forced to use all 8. You can save some computation gas and use just those 3 that can change. Okay, let's go on. The getStateFingerprint may include computed values, such as values based on a current timestamp. For example, expiration and maturity. Yeah, this is self-explaining. And the last is may include token metadata URI. I have read a lot of discussion about the metadata URI and a lot of like approaches which I found in the context of research, or in the research for this EIP. They were including the metadata. So if some token decides to use this state fingerprint for the metadata, yeah, why not? It can be. If it's part of the state, if it's considered part of the state, go for it. And the last but not least, the supports interface with this concrete hash must return true. This is basically saying, hey, it has to implement the ERC 165, and this hash is the interface ID of the EIP-5646, nothing more. I cannot stress this enough, so I created a standalone slide for that. But do not use state fingerprint as a sole token identifier. It has to be used with combination of contract address and token ID to act as a token identifier of a mutable token. Okay, so again, don't use it as a sole token identifier. It's not built for that. Okay, so let's go to some examples. This is example of a token bundler or token bundle ownership token. So let's say you have a bundler which is deployed as a different proxy, and you are tokenizing just the ownership. So the owner of this token can actually withdraw something from the bundle. It has two properties: is locked and nonce. I probably will not go through why it's here, but you can ask later if you're curious. But the state fingerprint will look basically like this. So the state fingerprint is basically just a hash of encoded values of this is locked flag and the nonce, and that's everything you need from that. With this implementation, any DeFi protocol working with assets implementing ERC-5646 can safely use this bundled ownership and sell it, use it as a collateral in the lending protocol, whatever you want to do with that. You can create a secure offer. Another example is a loan token. So this loan token represents a loan in a peer-to-peer lending platform. And you have a mapping, which is loan ID to a loan struct. The loan struct represents the state. The state has several properties. First is status, borrower, expiration, late repayment enabled flag, some struct for credit and collateral assets. You can see that there is just two properties which are mutable. It's the status and late repayment enabled. The borrower address and expiration, the credit and collateral assets are immutable. So in the state fingerprint function, you don't have to include all of them because, yeah, they will never change. So you can save gas here. And you can see that on the first line, there is the status. On the third line, there is the late repayment enabled flag. And on the second line, there is a condition, or we are computing this like computed property called is expired. So if the status is 2 and the loan expiration date is in the past, we consider this loan expired. So even though nothing happened on chain, nothing changed in the stored values, the state fingerprint can change because the time passed, the block timestamp is bigger, and the loan is expired. Okay, that was it. Thank you for everything. And if you want to read more about the EIP, please go to the EIP.ethereum.org pages or to ethereum-magicians.org, and please leave a feedback. Currently, there is just one post by me, so I would appreciate any constructive criticism is welcome. Or if you just like the EIP, you can leave a like, and I'll be happy.
Thank you. It was a nice presentation. Thank you for sharing that. I hope many others like me will find this helpful to learn about how this works and, of course, the proposal. So generally speaking, review is a status on the EIP standardization lifecycle where we hope to share information about the proposal with the community and collect constructive feedback to help the proposal become a standard. So As you already have shared the link to the FEM, hopefully we will get some more comments over there, and we see this proposal moving forward. Today, we are joined by a few participants of the call who are interested in learning more about the proposal. So first, I would like to open the floor for any questions from the present group.
Sure, actually. Great presentation. I did want to ask you a few questions just about the design, I mean, which you touched on, of course, but with returning a bytes 32, so like you demonstrated, the idea is that you can basically catch after ABI encoding the relevant details, and that way you're able to have one data type that's being returned. But I was wondering if maybe you could try and walk through the rationale on the usefulness, like using your example. So we want to know at a particular token ID, kind of various details about the status of a particular account or a particular transaction. When all we get is the fingerprint, normally if it would be, say, like 712 or any of the kind of signed protocols that we've seen, it means that someone else on the other end has to have the ability to kind of recreate the hash, so to speak. Like they would need to know on their own. Let me just take a look over here. So loans.states, what is that? Oh, it's status, isn't it? Sorry, I just need to make my screen a little bit bigger here. And then catch it and then call and then see if what's being returned is the same bytes 32 that they expect it to be. I'm getting a bit long-winded here. I probably should have thought about exactly how to ask the question a bit before I started asking it. But if that's making any sense, is that kind of what you're expecting at the other end here? That there's a front end or maybe another contract that's recreating the same data and then using get state fingerprint to check it on their end?
Yeah, I think I understand what you're asking. Even though the state fingerprint, if you know the implementation details, is deterministic, it's not meant to be deterministic in a way that the front end will actually build the state and use it in the offer. This is meant to be at the time when the buyer is creating an offer, it will ask the contract for the state fingerprint and include it in the offer. It will identify the token at the time of creating the offer or signing the offer. So even though you can do that, it's not necessarily, and it's not optimized for that.
So then how do you expect this to be leveraged to give details that are relevant to me, like right now, as in what would I be able to do in this case with the state fingerprint? I can get back a hash, but I don't necessarily know what's on the other end of that hash.
Yeah, exactly. And you don't need to know. That's the part of the problem, that we want to be able to identify mutable tokens without knowing the implementation details. So if we take example of ERC-721, you also don't know what the token ID represents there, right? There is some metadata which are off-chain, or there are some data which are stored on-chain. But still, you identify the token by the contract address and token ID, even though you don't know what exactly it represents. You need some additional information for that, right? So this standards is aiming just to take a snapshot of the state to protect basically the buyer or the lender, so the holder of the token cannot change the state and then accept the offer. So the offer is only valid for the state at the time of creating that offer. So maybe to answer, you will have to take a look into the token at the time when you are creating the offer. So if I'm a lender, I can see in the DeFi protocol UI that this is some kind of token. I can see the state. It will show me. But when I'm creating the offer, the protocol, the smart contracts, they don't need to know what exactly it is. If it makes any sense, I hope I answered.
I think so. I mean, if I'm understanding you right, you're talking about the integration concerns, which is that in order to integrate one of these tokens, the only thing they need to know, ERC-165 returns the right 4-byte, returns true on the right 4-byte sequence. And then they can assume there's a get state fingerprint. So integrating becomes very easy because they know, like, it's very predictable what they're getting back. I think what's bothering me the most is, I'm sure you've got a good answer for this. Like, I don't mean bothers, and I think I have like some crazy question here or anything like that. Is at that point that we've kind of reduced everything down to a bytes 32 hash, how useful is the hash? Like, what does the hash become useful for?
It's useful just to distinguish between different states. So by that, I can just check that the state didn't change or change. That's basically the only information I need. So if the offer is valid or is invalid.
How would I know that that's what changed in this state, though? Like, maybe in this case, late repayment enabled changed.
I don't need to know what changed. I just need to know that it changed. If I would like to know what exactly changed, then I would need to know the implementation details, right? And that's the part I said I don't want to know. I want to, like, as general as possible. So yeah, basically the same thing as the ERC 721. You can have additional data stored to the token ID, right? Even if we don't have this get state fingerprint function, you know there is some loan which has stored this status, borrower, expiration, and so on. But you don't like need that to identify the token. Like the ERC 721 is not saying anything about additional data. And this EIP or ERC 5646 is just about like having the tools to distinguish if the state changed or not.
I understand. All right. Thanks. Thanks for answering that. Yeah.
The EIP 1180 I mentioned before, I think they were trying to actually like solve, I think, the problem you have on your mind, that the buyer or the lender can specify what exactly can change and what cannot change. So for example, in this like loan token, I as a buyer can say, hey, I want the status to be the same. I want the loan to be or not to be expired, but I don't care if the late repayment enabled flag is changed or not. This was the proposal 1180, but that necessarily means that you need to know the implementation details.
Yeah, I hear that. Okay, yeah, I understand what you're saying. Thanks.
Hey, Naim. That was a great presentation. I am still trying to get kind of to understand the attack vector here. So, you know, I get that basically the rug can be pulled out from underneath you between like getting this NFT and then when you're going to sell it. So I just want to like understand that attack a little bit more. Like, what would the adversary do?
This basically?
Yeah, that one.
Yeah, so imagine part of the offer is identifying what you are trying to buy, right? So currently you can identify any token by a contract address and the token ID, because that's the standards for that. Otherwise, you would need to know the implementation details. So if you want to sell, for example, the Uniswap V3 LP NFT on OpenSea, and somebody gives you an offer, you can withdraw all the liquidity and not change the token ID nor the contract address. So in that case, the buyer is actually creating offer not on the token itself, but on the state of the token, on the underlying assets. But they can be withdrawn from that. So this is like the case.
So
yeah, sorry, go on.
So does that come down to like the block level ordering of transactions? So let's say I said someone wants to sell their LP token, and then I place a buy order. The seller, who is like evil in this case, wants to basically put their withdrawal transaction just before my buy transaction. Is that sort of what we're talking about?
Yeah, but like currently you can list your token or you can get an offer, right, from a buyer directly, and you can accept the offer even as a seller. So you don't have to do this front running thing. But you can, if you list the token and somebody wants to buy it, believing that, okay, this is my transaction, so he will not be able to withdraw it. And the seller is evil enough to do this like front-running attack, then yeah, he'll be able to withdraw the liquidity without changing the token ID and basically rugging the buyer.
Yeah, and then I guess the other question was, it sounds like the implementer of this EIP needs to kind of be careful about using these like variables that can change without them kind of realizing. So for example, like if they did use like block timestamp in there, which changes all the time, they might invalidate an order accidentally. That like maybe the block timestamp wasn't actually kind of meant to be there. It feels like you've already kind of done it in your notes there, but like calling out how important it is. But it's just like there's kind of nuance there, right? Where it's easy to accidentally put something in that mightn't meant to be.
Yeah, definitely. It's the responsibility of the implementer to do it responsibly, right? If you put the block timestamp directly into the state fingerprint, the state fingerprint will be different for basically every time if you are not asking in the context of one block, right? So you can use the block timestamp in part of like a condition, which is used here, but not directly, because then it would not make sense. It will always change, and basically any offer created this way, like using the EIP-5646, would basically fail, would be invalid. So yes, the implementers has to be careful about that. They have to really know what the state is, even though it could be like computed properties or stored properties.
Cool, thanks.
Well, thank you. I think I have a couple of questions to go over. My question is based on the information shared on FEM related to state fingerprint update event. So maybe if you could talk about a significance of state fingerprint update event, and why is that not a part of current specs 5646?
Yeah. I put it into the Ethereum Magician discussion post as an open question because at the one hand, it makes sense to trigger or emit an event for the UI to know that the state fingerprint did change. But on the other hand, for example, here you can see that the state fingerprint can change even though there is no like transaction involved. So I wasn't really sure if I want to give this false sense of security that it's going to be triggered every time. So that's why it's an open question, and I would like to see, I would like to hear like a pros and cons. But if it want to be up to me, I would not give it there just because it's not covering 100% of the cases where the state fingerprint can change.
That make a lot of sense. When we are trying to create a standard, we don't need to be very specific. Giving flexibility will increase more adoption, I suppose.
Yeah.
All right. My next question is about proposal implementation. You did mention about a couple of projects who are implementing, I think, blockheads and mocons, that you mentioned that they are probably implementing it. So are they implementing this proposal, or maybe a version of this proposal that may have inspired you to come up with this proposal?
No. They are not implementing this proposal. They are deployed, I think, several years now. So it's just the like assurance that, yeah, this problem exists in a space, and it's not like standardized yet. So there is a lot of different, or at least 2 different implementation of the same thing. So if we want to support them, we would need to support them individually. So instead of doing that, we can have a standard just agreement on how the state fingerprint function looks like, and use that throughout the whole mutable token space.
I got it. I think somewhere you also mentioned that the existing project may be able to implement this proposal with some changes in the protocol level.
Sorry, what do you mean?
if I remember correctly, reading about the proposal, somewhere it has been mentioned that it is possible for existing DeFi protocol to also adopt this proposal 5646. So what would be the workaround for existing project to maybe deploy this?
Basically, the idea is the same as you have an official wrapper, so you will have official state fingerprint computer. It will be like a standalone contract which would implement just this get state fingerprint function, but it will count the state fingerprint from already deployed like token. So it won't be part of that token. So the discoverability will not be there, but it's some like a trade-off, like a workaround, how to actually implement the function to already deployed tokens. So yeah, the DeFi protocols will still have to have some kind of like mapping of this deployed legacy token has this address which implements the state fingerprint function, but yeah, at least it's some way how to do that after the deployment.
That makes sense. So generally speaking, it is recommended to EIP authors to be working with a team to maybe come up with a prototype and maybe implement this proposal. So curious if you happen to be working with any team, or if you know that some group is maybe interested in implementing this proposal.
Honestly, no. This EIP came from the issue PON. So we want to support mutable tokens. We want to enable mutable derivative tokens to be used on the platform, used as collateral, without going through this like, hey, I'm losing ownership to some bundle and using that. So we want to make it more like native. So no, I'm not working with any like external team. But these two implementation, that's actually from our token bundler and the loan token we use. So at least using this EIP, and we'll be deploying it shortly.
We lost you for a couple of seconds, but I hope you were mentioning that at least Project PON will be deploying this EIP.
Yes, exactly. I was saying that.
Sounds good. Like having a prototype or a real project implementation definitely gives confidence to other dapp builders to adopt this EIP, and also to the EIP editors to move the proposal to the final status. So it's good to know that this is under consideration for at least one project. Another question is about security consideration, though this proposal seems to be like a lighter version of any other standard. Is there any special security consideration that dapp developers might want to consider while implementing this proposal?
Yeah, well, for the DeFi protocol developers, they should not use it as a sole token identifier. And for the token implementers, they just need to be sure that all the mutable state properties are included in the computing of the state fingerprint. Otherwise, just not use block timestamp directly, because then you will have always the different state fingerprint. And other than that, I don't think there's any other security issues.
That's a good piece of advice. Depending upon the kind of project someone is working or developing, may consider these important factors to implement EIP-5646. Well, I understand this is the first proposal that is coming from your end for the Ethereum repository. I wonder if you have any thoughts on the process that you would like to share with us.
Yeah, well, that's true. It's my first. It was quite a journey. Yeah, I was reading, of course, the EIP 1. I was reading a blog post from Annette Rohrikova. She's very active in the Ethereum Magicians community. And yeah, other than that, I don't know. I would like to get an answer to when you can actually move the EIP to the last call, or what does it mean to have like community feedback? Because yeah, I understand that now it's a little, but what's the threshold there? So this, like, a transition functions could be defined a little bit better, but other than that, I think yeah, it's a fine journey. It's about the content more than the process.
That's right. To answer your questions, generally it is on the author to move to the proposal to the last call when it is assumed that there would not be any significant specs change expected with the proposal. As soon as an author gets confidence, they can create a pull request to move it to the last call. However, with respect to ERC proposals, the general recommendation is to have it backed by some kind of implementation or reference implementation. That generally helps to like move the proposal towards the final status. After the last call, there is a wait time of 2 weeks in which a proposal is again reviewed by EIP editor and obviously by community. And if there is no strong recommendation for changes coming up, then the proposal is moved towards final status after the last call period is over.
Thanks.
I would like to make a mention here that I found that this proposal is making a very good use of discussion to thread to provide the background related information to help readers understand why this proposal needs to be a standard. Kudos to you as an author that you tried to be respectful of the Ethereum EIP standard repository and didn't put everything in the .md file. So yeah. That was really nice. I hope many other authors may get some inspiration.
Thank you. Thank you. I think I made that mistake, but then change it. So yeah.
But I think it is a good example that we can probably share with others to follow along.
Perfect. Thank you.
All right, it's time to wrap up. Naim, we appreciate you taking out time to join us today and share about the upcoming standard EIP-5646 token state fingerprint. I hope with this talk, aspiring dapp developers may have learned about the proposal, application binary interface, the ABI, and the importance of a state identification of a derivative token. We look forward to have increased adaptability of this proposal and the proposal to be moved forward to the final status. And on this note, thanks to everyone watching or listening to this special episode on DeFi standard. Should you have any question, let us know in the form available in the description or leave a comment or reach us at Discord. Check out descriptions for links to useful resources and guest Twitter to follow. We will be back with another interesting proposal overview next week. Till then, keep watching, keep sharing your love with Ethereum cat herders. Cheers.